Welcome to our presentation on autonomous driving, created by Group 10, which consists of John Culver, Adam Hahn, Joanna Naziri, and Alexandra Oliver. We will cover a number of topics related to autonomous driving. First, we'll cover an overview of autonomous driving, then a history and timeline of its development, its relevant IT components, uses and implications, costs, benefits, risks, and some future trends.
Hello and welcome. Today we'll be discussing the technology behind autonomous driving, also known as self-driving vehicles or autonomous vehicles. To start, we're going to give an overview of the technology, and to do that, we're going to discuss the different levels of automation. There are 5 levels of automation in vehicles today. However, we do want to start with level 0 because there's a couple important things to note about level 0. Level 0 was the base for creating some type of driver assistance technology. In a level 0 vehicle, there are no automated assistance technologies. However, there usually are some type of driver assistance available in these vehicles. So something like fixed speed cruise control or a hardware system that can warn of an impending crash. The important thing to note about level 0 vehicles is that there is no vehicle intervention. So level 1 automation is driver assistance. Most modern cars qualify as capable of level 1 today. To meet this requirement, a vehicle must have at least one advanced driver assistance feature, so something like adaptive cruise control. Um, the mobility is supervised by the human, but for convenience, the vehicle is capable of maintaining its own speed under certain circumstances. So, one level beyond level 0 is a type of technology that the vehicle can take control in certain instances. Level 2 is partial automation. So, a level 2 vehicle has 2 or more advanced driver assistance systems. Um, so, these are going to be systems that can brake the vehicle, steer the vehicle, or accelerate the vehicle. Examples of this technology include adaptive cruise control, active lane keep assist, or automatic emergency braking. It's important to note that these technologies still require human intervention to control the vehicle. However, the vehicle can make decisions on its own in certain circumstances. A couple examples of these types of systems are the General Motors Super Cruise, Mercedes-Benz Distronic Plus, Nissan ProPilot Assist, or one that we hear about a lot, Tesla Autopilot. Level 3 is conditional automation. Level 3 has a huge jump in complexity from level 2. A level 3 vehicle is capable of taking full control and operating during select parts of a journey when certain operating conditions are met. For example, a vehicle that has level 3 automation can get itself on and off the freeway. It can complete city driving. This level of automation requires an advanced sensor package, hardware backups, and sophisticated software to keep occupants safe. Today, there aren't many level 3 vehicles. You may have heard in the news recently of a crash involving an Uber. There was a pedestrian fatality in that crash, and that was a level 3 automated vehicle. Audi intended to release their 2019 A8 with their AI traffic jam pilot system, which would have made it the first level 3 street vehicle available to the public. However, it's still waiting legal approval in many countries, including the US. Level 4 vehicles are vehicles that have high automation. So this is where the vehicle would essentially be able to take control and complete an entire journey on its own. However, there may be some type of constraint in a level 4 vehicle. So for example, if a vehicle had full automation, but it was confined to a certain geographical area, or if it was prohibited from operating beyond a certain speed, that would be a level 4 vehicle. Level 4 vehicles will generally have driver functionality available. So there'll still be a steering wheel in level 4 vehicles. There'll still be gas and brake pedals. There are no level 4 production vehicles available today. Level 5 is full automation. So essentially what this is stating is that the driver or passenger would be able to get into the vehicle and fall asleep in the back seat and expect to arrive safely at their destination. Just like level 4, there are no level 5 fully automated vehicles on the road. Now we'll discuss the history of autonomous driving. To discuss the history, we're going to talk about certain features that were made available in vehicles during certain periods or during certain waves. The first period that we're going to talk about is from the years 2000 to 2010. This is when we saw the release of advanced safety features. So this is where we're going to find vehicles that have a level 0 automation. So there are some features above what has been historically seen in vehicles to assist the driver. The big piece to remember here is that there is no vehicle intervention. So for example, blind spot detection is an advanced safety feature. This would warn the driver of somebody in their blind spot. However, the vehicle would never intervene to prevent the vehicle from switching to a different lane. From 2010 to 2016, we saw the release of advanced driver assistance features. So this is a build on advanced safety features. Advanced driver assistance features are available to provide vehicle intervention. So for example, pedestrian automatic emergency braking is an advanced driver assistance feature. If a person is driving a vehicle and a pedestrian jumps out in front of their car, the vehicle can sense that and stop automatically. Each of these systems will be functioning independently from one another, and in order to fit a level 1 vehicle, there has to be at least one of these features available. The next period we'll discuss is where we are at today. So from 2016 until approximately 2025, we don't know for sure that's when this period is going to end, but when it's expected to. We're in the period of partially automated safety features. So essentially, we're looking at vehicles at level 2, possibly even moving a little bit into level 3. If you remember, level 2 vehicles have the advanced driver assistance systems that work together. For example, the most popular vehicle available today that is part of this period is a Tesla with its autopilot system. So these are multiple systems working together to help the vehicle drive autonomously in certain situations. So for example, technologies like lane keeping assist, adaptive cruise control, traffic jam assist, and self-park are all partially automated safety features. Moving forward, there is not necessarily an estimated time frame, but we will see additional periods. So in the near future, we'll potentially see level 3 and level 4 vehicles have their own periods as well.
So, as we learned in this class, information technology is the design and implementation of information or data within the information system. Autonomous driving really puts these IT systems in the spotlight because they would not even be possible without the coordinated effort of an entire information technology system within every single vehicle. There are many technologies involved that make self-driving cars even possible, such as different sensors, connectivity, and software and control algorithms. The technology that plays a role in operating these vehicles can be divided into hardware and software. So the self-driving machine must use all of these technologies to receive and communicate the inputs, make decisions based on algorithms, and then communicate those decisions to components that can manipulate the speed and direction of the vehicle. So I'm going to go into each of these technologies with a little bit more detail. The first part of the hardware is the sensors. A sensor is a device that detects any changes to the car or property. Many of the sensors required for autonomous driving are used in safety features such as blind spot monitoring, lane keep assistance, and forward collision warning. This is a direct quote that came from Alan Amici, a vice president of automotive engineering at TE. Sensors also provide the necessary means to navigate the car safely, and some of the examples of them are radar, ultrasonic, and cameras. So during perception of the environment, all the multi-sensors are deployed to sense the information from the environment, which are then fused to perceive the environment. There are several sensors involved, such as the laser sensor, which is utilized for bridging between the real world and the data world. The radar sensor is used for distance perception, and then the visual sensor is for traffic sign recognition. The second part of the hardware we can describe as the connectivity. So the connectivity ensures cars have access to the latest traffic, weather, surface conditions, construction, maps, and road infrastructure, which Alan Amici also describes. This data is used to monitor a car's surrounding operating environment to anticipate braking or avoid any hazards that were to come forward. For example, information on driving conditions such as icy roads, traffic slowdowns, or tolls can also enable vehicles to interpret data and make automated decisions such as choosing another route. So all of this information is part of the hardware that is required for autonomous vehicles to function. But the software is equally as important. So I like to think of hardware serving as the body of the vehicle, but software really serves as the brain. So software is what processes the information and informs moment-by-moment decisions like whether to slow down or speed up. The autonomous system needs to sense the environment, needs to determine the exact position on the road, and needs to decide how it should behave in a given situation. That is why self-driving cars are highly dependent on software as well to bridge the gap between sensor physics and the mechanical hardware of the vehicle, such as the steering and brakes. There are several core algorithms and software components to make these vehicles possible, which can be broken down into several, but I've kind of combined them into three, which is the perception, localization, and planning. These are needed to reliably capture the data from sensors and connectivity, which were the previous two technologies we discussed, and make decisions on steering, braking, speed, and route guidance. The software is also truly a complex part of autonomous cars because it is the decision-making of the technologies and algorithms that must be able to handle a multitude of simple and complex driving situations flawlessly.
Although autonomous driving can be the next best technology advancement, there are some implications that occur with this system. Some of these include issues on a personal, industry, and environmental level. For example, from a personal related perspective, autonomous driving can be burdensome to the consumer. If a consumer decides to purchase an autonomous vehicle, then this drives up household expenses because the average cost of an autonomous vehicle is more expensive by 7 to 10 grand more than the current conventional vehicle. This also doesn't include battery warranties and electrical bills for your car because the car will now need to require charging of it since it's all electric. In addition, these autonomous vehicles are composed of more Wi-Fi, electrical components, and radio frequency technology, in which all of these emit more electromagnetic field radiation into the environment. There have been studies that have shown to date the more exposure to EMF, the more dangerous it is for people's health. From an industry perspective, there are many implications that can occur from autonomous driving. Some of these involve major areas of concern, such as funding of public transportation. If autonomous vehicles exceed the sales of conventional vehicles, then there will be more consumer demand to adjust the highways, charging stations, and roadways to accommodate autonomous vehicles. If consumer demand increases for autonomous vehicles, then there will be a movement towards the autonomous vehicle transportation system, shuttle services, taxis, and other ways of transportation. This means that the government funding of current public transportation of subways, train stations, buses, and taxi services will fall in monetary and public importance. Other implications involve decreased jobs for those who work in the transportation industry as well, or others who work in power grid plants, and even the mechanical maintenance of conventional vehicles. If the economy shifts towards autonomous vehicles, not all average households can afford such advanced vehicles, which means that there will be less loans, less consumer credit being built, potentially making the lending industry close to non existent. Since these autonomous vehicles contain more software and network connectivity, this increases the threat of cybersecurity. Now, there are more ways for hackers to actually hack the autonomous vehicle. These hackers could potentially gain access to a driver's Wi Fi or Bluetooth and potentially hack the car's driving methods. Or they might be able to even gain access to personal data or information that was stored or embedded into the vehicle's memory. From an environmental aspect, implications that affect the environment around us include potential increased air pollution, only if the influx of autonomous cars operates off of gas. Since these cars don't have a human mind, they will not be conscious of how much gas they're consuming or guzzling down. Now, if these autonomous vehicles run off of electrical power only, then this could pose a threat to natural resources and economic trade because there would not be a high demand for gas. If there's less demand for gas, then that means that there's less trade power for imports and exports. Another economic implication is the potential landfill buildup. So, if these autonomous cars will be filled with more technology than the existing cars, then unfortunately that doesn't last forever, and those particular components don't degrade, which means that the landfills will now be filled with more and more electrical components, software drives, and other components that go into these vehicles. The last implication that can have a negative impact on the environment is the increase in power grids. This also is a part of the increased EMF exposure that we were talking about, and it also impacts the existing market of power grids. The more autonomous cars means that existing power grid companies can lose their jobs because more companies, such as these car manufacturers, will dominate the power grid industry and start buying more of these grids to aid in their wealth of the autonomous driving industry. A lot of these car manufacturers will then be large corporations, which will dominate the industry and create a monopoly, which is not good for the natural landscape from a money perspective, which impacts the economy, and also from a natural landscape perspective, because this means that more autonomous vehicles means more power grids that need to be larger and more equipped to go up. Autonomous driving can be utilized for many different things. Before we know it, the streets will be filled with more and more self driving cars, and these cars will be the future of household vehicles, where people will buy these for their everyday transportation method. These cards are more of a convenience for the average citizen because now you can work while you drive, you can study, you can take conference calls. You can now trust a vehicle to drive for you, which means you can focus your attention on the tasks that you want to be doing, which are related to work or school, instead of focusing on the road. There is now a greater advantage for road trips because, as most people love to do, you can get some extra Z's and you can now nap because your car is driving for you. So these autonomous vehicles can be very enticing to the consumer. Another great aspect is that these cars can now assist with improved quality of life for certain disabled persons, such as the blind or the deaf. These people cannot drive conventional cars because they're not equipped to do so. They do have to pay attention to the road, and sometimes that can be very hard for those certain people. So these autonomous vehicles allow them to go from A to B destination rather easier since they can rely on the car to drive for them, creating better transportation for disabled people. Regarding the industry itself, self-driving cars will be the era of the future. So consumers and industries will want self-driving cars because number one, it can save on gas, employee costs, and number two, it can be more efficient and pleasant to drive in a car that does everything for you. Autonomous vehicles can also aid with logistics by changing the way that we deliver small or larger items. Self-driving cars can travel short distances and long distances, and this can be great for local deliveries of groceries, maybe Amazon Prime deliveries, possibly even the US Postal Service's mail deliveries. Also, the cars can deliver specific items that qualify for delivery via cross-country, which enables long-term logistics as well. As with everything, autonomous driving certainly has some significant associated costs. So some of these are listed here. For example, gas would be considered an incurred cost to the industry since the economy is no longer purchasing as much fuel with conventional vehicles, which causes the trades to be purchased elsewhere. Although incurred to the industry, consumers would actually save money on the autonomous vehicle transfer since they no longer have to purchase gas for electrical vehicles. So they could potentially be saving an average of $1 to $2 grand a month on not buying gas for a conventional car. Capital maintenance is the simplicity of consumers saving money on not repairing the hardware components that exist in current conventional vehicles. Hardware and software is now being used more in the automotive industry because there's a move towards automated cars, which means that the cars are more expensive due to the advanced technology. Raw materials apply to the car manufacturer because there could be a cost savings due to not having to purchase as much raw materials related to mechanical parts, oils, and fuels to operate the vehicle efficiently. R&D costs will now rise since there is more software in the vehicle that needs to be tested. Auto insurance may increase or decrease for consumers. It is too early to tell which way the insurance industry will swing because there are not as many self-driving cars now as there are projected to be in the future. So these insurance companies may believe that these autonomous vehicles are safer, which means that insurance coverage may drop in price, or they may think that they're more dangerous due to the technology, which means that insurance premiums could rise. The vehicle price will most definitely rise due to the advanced technology in the vehicle, and car manufacturers will want to make a return on investment on the particular finished good. Transportation services will be more expensive for autonomous vehicles because these transportation companies will convert to autonomous cars, which are more expensive in the long run, which means that consumers are going to take the hit on this. The import of gas will decrease, while exports may increase because we need to make up for that natural resource trade somewhere else. And finally, it will cost more money to expand the roadways and equip them to be autonomous vehicle friendly.
While the debate for autonomous cars is still ongoing, there's no denying that the benefits of self-driving vehicles are many. The sensors in a self-driving car are always observing, are not affected by the state of the driver, whether sleepy or angry, and can scan in multiple directions simultaneously, says Dr. Dominique Freckman, an automotive engineering manager at TE Connectivity. So this plays a large factor in explaining why there are several safety benefits to autonomous vehicles. Automated vehicles' potential to save lives and reduce injuries could largely change one devastating fact, which is that 94% of serious crashes are due to human error. So automated vehicles have the potential to remove human error from the crash equation, which not only can protect the drivers and passengers in the vehicle, but also bicyclists and pedestrians. Further, being able to have a self-driving vehicle can add benefits to society as a whole, such as providing transportation for people who are otherwise not able to drive, either due to disability or because of the age. Further, economic benefits could also play a vital role as the roads become safer. So, in his study of potential economic benefits of driverless vehicles, Hideaki Tomita, a professor of Faculty of Economics at Hiroshima University, says that improved efficiency in the use of roadways translates into increased roadway capacity, and it is estimated that this would result in approximately 488 billion of cost savings through a reduction in injuries and deaths caused by car collisions. Not to mention that it will also add a huge influx of tech-based jobs. Another study by NHTS showed motor vehicle crashes in 2010 cost 242 billion in economic activity, including 57.6 billion in lost workplace productivity and 594 billion due to loss of life and decreased quality of life due to injuries. Eliminating the main reason that these motor vehicle crashes occur could erase these costs. Finally, a lot of our time in the US is spent driving from one place to another. So another benefit would be eliminating this completely. Eliminating the need to drive could give us so much more time to accomplish other tasks such as reading, working, talking, or even sleeping. Autonomous cars can make this possible. The boost in overall driver productivity could then result in a more efficient and less anxious population. Overall, the emergence of fully automated driverless vehicles will have a tremendous impact on our society, bringing fundamental changes to the entire economic and social systems.
Since autonomous driving contains more hardware and software, there are now more things that could possibly go wrong. These risks vary from increased accidents to EMF exposure. Just because autonomous vehicles are convenient doesn't necessarily mean that they're safer. Roadways need to now be equipped for such vehicles, and there are many features that are unpredictable, especially regarding weather conditions. No car can 100% be prepared for all of the weather scenarios that can occur on a daily basis. If Mother Nature takes its course in dramatic fashion regarding rain or hail or sleet or a snowstorm, there's no way that the car can be able to handle all of these bad weather scenarios or conditions, and this may cause the car to actually create an accident on the road. The industry is also unregulated, which means the R&D testing could be limited and the software may not be tested to detail safety standards or requirements that it needs to be, so this could be hazardous to the consumer itself. With all the technology, there's always a certain level of error and glitches that can happen at any given time, so this would definitely apply to the software and hardware that exists within these autonomous vehicles. As stated previously, there is a huge threat to information and data hacking from external users and also an increased exposure to EMF activity, which can also increase health problems to people.
There are nearly an innumerable number of future potential trends when referring to autonomous driving. A few of the most noted ones are listed here. The first is the intelligent grid, of which there becomes a vehicle cloud, which has kind of been pioneered by Google, where vehicles are essentially able to learn and communicate with each other without the input of humans in a system similar to the Internet of Things, which a good example is an HVAC system in a home with different sensors in each room to control the temperatures of each room individually without human input. And what this kind of leads to is the next point, which is platooning, where vehicles can essentially form groups that are going to similar destinations or traveling similar paths, where these vehicles will communicate with each other directly in ways that will improve the efficiency and better use the limited road space. Examples of this are the vehicles traveling on highways can group or cluster together and create very small distances between the vehicles because they're all communicating and reducing both the volume or the actual area of road being used, but also reducing the number of lane switches and lane changes, which is all in the name of safety. Another example is at a stoplight, when the light turns green, instead of humans where one car starts moving, then the next car starts moving, then the next car starts moving, all of the cars in this platoon will move together at the same time, creating a more efficient use and more cars getting through. There's also the improved land use, which results from no longer needing significant sized parking lots around stadiums, shopping malls, and other areas that see a lot of parking. And it also could result in the reduction in the number of garages in homes, which will either allow more land space or just more home space on the same footprint. And the last common noted trend is that there will be an impact on jobs. The most noted are the taxi, Uber, and Lyft drivers. With autonomous driving, there wouldn't be a need for these jobs, though the service would still exist. And of course, jobs to maintain autonomous vehicles will be created. But the other is shipping company logistics. One, both the drivers may be affected, but also the ability for the shipping vehicles to communicate with each other and be more efficient in dropping off goods at different places or arriving at the same places at the same time in order to transload or transfer goods from one vehicle to another without any downtime can have serious efficiency improvements. We've discussed autonomous driving at length in this presentation. What we've learned in the research is that autonomous driving is somewhat of an inevitability. There's been a lot of funding, a lot of research, and a lot of government funding in this project, as it should. The technology will create an immense impact on our economic world, anywhere from taxes to consumer credit, to the safety of travel, to the efficiencies of business, and also even unforeseen things like land efficiency in both homes and parking lots. The technology, when at level 5, should improve safety among transportation to an exponential level. Once the technology is driven and once AI has been incorporated effectively, the amount of accidents, especially caused by just human error, should be reduced dramatically. We've already seen a little bit of that today. And lastly, autonomous driving is going to have a paradigm shift in the way we travel. It'll allow us to continue to work and complete tasks, to eat while traveling, and it'll also improve efficiencies, as we've said, for businesses and consumers alike.